So function f and g are defined by fx equals x square minus 4x plus 3, and the domain is greater than c, where c is a constant, and gx is 1 over x plus 1, and its domain is x is greater than minus 1. Part A says express fx in the form of x minus a whole square plus b, that is in completed square form. Okay, so fx equals x square minus 4x plus 3. And for to change it into completed square form, I'm using the identity method a square minus 2ab, sorry, plus now this is a and this would be b. So we'll have to add 2 square, and then we'll also have to subtract it. And there's also a plus 3 with the question. Okay. These three combined give us a minus b whole square, and these two combined give us -1. So we have x minus 2 whole square minus 1 as fx. And also I'm writing its domain next to it because it might come in handy in the next part. Part A is done. Part B says, it is given that f is a one-to-one function. Find the smallest possible value of c. Okay, now if it's a one-to-one function, then it must pass the horizontal line test. Okay, for that, I'm going to first sketch this curve. The turning point of this curve is 2 comma -1. We know that from quadratics. So 2 comma -1. This is the turning point. It's going to be a U-shaped curve passing through 3. The y-intercept would be 3. So a curve like this roughly. Okay, now this is so not a one-to-one function, but if x is greater than c and we start x from here, then this part of the graph, here the horizontal line test passes at every point, because the horizontal line test would now cut the graph at only one point if we're only considering the black portion of the graph. So then what is the smallest possible value that c can take? It's going to be this 2. So c is equals to 2 is the smallest value that can be taken, so that this becomes a one-to-one function. Okay. Part C is, it is now given that c is equals to 5. So I am rewriting this as x is greater than 5 for part C. Okay. Find f inverse and state the range of f inverse. So to find f inverse, let's first replace fx with y. It'll be y plus 1, and also x is greater than 5. Okay, y plus 1, square root plus minus 2 goes to the other side, becomes plus 2 is equals to x. So we're getting 2 plus minus, we're going to talk about that in a second, and x plus 1. Now, do we choose the plus sign or do we choose the minus sign? Only one is chosen, and it depends upon the domain of fx. The domain of fx is greater than 5. That means it is increasing. So the range of f inverse of x will also increase. So 2 plus square root of x plus 1. If it were less than 5, then we would have chosen negative sign. Okay. Next, we also need the domain of f inverse. So domain of f inverse is equals to the range of f. So let's write that down. Domain of f inverse equals range of f. Now I'm going back to f. This is fx equals x minus 2 whole square minus 1, where x is greater than 5. Now, if x is greater than 5, then fx is going to be greater than, substitute 5 here, 5 minus 2, 3, 3 squared is 9, 9 minus 1 is 8. So as x is greater than 5, as x becomes bigger than 5, fx becomes bigger than 8. So that is the range of fx, which is also going to be equals to the domain of f inverse. So we're going to write x is greater than 8. This is the answer. Okay. Part D says find GF and state the range of GF. So we know what is fx, and x is greater than 5. Now let's also write gx and its domain. Gx is, we're doing part D. Gx is 1 upon x plus 1, and its domain is x is greater than minus 1. Okay, now let's find gf. So in f, we have to substitute g. So, sorry, in g, we have to substitute f. So it's going to be 1 over x minus 2 whole square minus 1 plus 1. This is gf, which gives us gf equals 1 upon x minus 2 whole square. Okay. Says next to find the range of gf. Now, range of gf would obviously depend upon the domain of gf. First, we need the domain of gf, and then using that domain, we should be able to find range. So the domain of gf is the same as the domain of f. We studied this in class. So again, I'm going to repeat that domain of gf is the same as the domain of f. And what was the domain of f? It was x is greater than 5. So this is greater than 5. Now let's substitute 5 here. We get 1 upon 3 squared, which is 1 upon 9. So one of the extreme values will be 1 over 9. And as x increases, the denominator keeps getting bigger, and the fraction 1 upon big number becomes almost equals to 0. So as x increases, it becomes 10, it becomes 30, it becomes 80, it becomes 500. Then this fraction starts getting smaller and smaller and smaller, but it will be never equals to 0, because even if you divide like 1 by 80 billion, you will get 0.0000, lots of zeros, and then 1 in the end. So it's never equals to 0. So this value is going to fluctuate between 1 by 9 to 0. Because at 5, you get 1 over 9. And if you keep increasing x, you get almost 0. So then you write that the range of GF will be between 0 and 1 by 9. We will not write equals to sign with either of them. Okay, this is question 21.